This is Dr. Holt. In this video I want to talk about how to calculate the moment of inertia of a uniform disk based on the equation that I is equal to the integral of r squared dm. What I've done here, I've established a small cross-section, has a very thin thickness of dr. We can say approximately this area here, we'll call it dA, is approximately equal to 2 pi is the radius, which is going to give you the circumference, times the thickness of dr. That's very, very close to the area of this if we let dr approach 0. It's a very small thickness. Well, here I have the entire uniform disk. It has a mass of m. So if I want to find approximately what dm is, then I'm going to take the entire mass, I'm going to divide it by the entire area of this disk, which would be pi times big R squared, where big R is the radius here. If I take that and then multiply it by dA, the area of this, I will get approximately dm. So let's do that. I'm going to take big M over pi times R squared. I'm going to multiply it by 2 pi times R times dr. And again, that's going to establish what dm is going to be. Alright, so now we're going to use that information, we're going to put it back in for dm up here. So I'm going to grab this and just bring it down. Slide down, give myself some space. And take out my dm. I'm going to put all that information in, which will give me 2 pi r dr. Now here, oh sorry, I need to get my m over pi times big R squared. Okay, I'm going to pull out everything that's constant. Big R is not going to change. So we can say I is going to equal to, we'll pull out everything we can, 2 pi, we'll pull that out, times big M over pi times r squared of the integral of r squared, and then I'll go ahead and do the multiplication. I'll talk about it first, of this value here. Alright, now here the pi's will cancel out. Here, now the r squared is going to be the distance from the center to the center. So in this case, this will be little r. So we're okay there. So we'll go ahead and change this then to be r cubed. R cubed. Oops, I'll do that in block. Sorry. R cubed, and then we got the dr. Now we're going to integrate from 0 to r. So we integrate that, we will get I is equal to 2m over r squared of r to the 4th over 4. And we're going to be putting the values of r and 0. So let's go ahead and simplify this a little bit. We can cancel the 2 out here, and this would become a 2 here. So now we'll have r 0 of big M over 2, oops, maybe make that big R2. Big M over 2 over big R squared of r to the 4th. Okay, I put the values m in. That gives me I is equal to m over 2 r squared of the values of big R to the 4th minus 0 to the 4th. Scroll down, and that's going to give me I is equal to big M over 2 big R squared of r to the 4th. And we simplify that, that will give us 1/2 mass times big R squared. And that's how you generate the moment of inertia of a uniform disk using integration. And again, that value matches what you'll see in textbooks. All right, best of luck.